Welcome to our channel, a quiet place for slow nights, soft thoughts, and gentle sleep. Tonight, begin with your body. Feel yourself resting where you are. Feel the weight of your body softening into the bed. Your shoulders can loosen, your hands can rest, your breathing can slow, just a little. There is nothing to remember, nothing to take notes on. Nothing you need to follow. Just settle in and let the day drift away. Tonight, we drift gently around the planet Saturn and through the soft architecture of its rings. The rings have been turning quietly for longer than anyone can truly say, and they will keep turning long after this moment has passed. You do not have to follow closely. You can simply float. You can breathe. You can let the universe do the talking. And as your body rests here, safe, still, and heavy, your imagination begins to move slowly through the silence of space. Saturn glows in the distance, calm, golden, and waiting in the dark. Saturn is far from here, far enough that the light leaving its rings tonight will not reach your sky for over an hour, even moving as fast as light can. The planet itself is a soft pale shape, the color of cream and honey, banded in slow weather that takes years to change. And around it, almost flat against the dark, is the thing that makes Saturn unmistakable. A wide, gentle disk of ice and dust and quiet motion. The rings. If you have ever seen Saturn through a small telescope, you have seen what Galileo saw in the year 1610, when he first turned his lens toward the planet. He didn't quite understand what he was looking at. He thought the rings were a pair of handles, or perhaps two small companions on either side of the planet. He wrote about it gently, in the careful way of someone who knows they are seeing something, but cannot yet say what. 2 years later, when Earth had moved to a different angle, the rings appeared to vanish, and Galileo, in his confusion, wrote that Saturn had eaten its own children. He didn't mean it dramatically. He meant it the way someone might describe a magic trick they had not yet figured out. It took another 45 years before the Dutch astronomer Christian Huygens looked through a better telescope and finally understood. The rings were not handles, and they were not companions. They were a thin, flat disk, tilted around Saturn like a brim of a hat. Huygens wrote it down in a single calm sentence, and the world has known ever since. What he could not have known, what no one knew for centuries afterward, is just how thin that disk really is. The rings, from one outer edge to the other, stretch across about 280,000 kilometers. That is wider than the distance between the Earth and the Moon. And yet, for most of their span, they are only about 10 meters thick, about the height of a small 3-story house. Imagine a sheet of paper stretched across a city, or a layer of frost, the width of a country. That is the shape we are drifting through tonight. There is a way of putting it that astronomers use sometimes. If you shrank Saturn down to the size you could hold in your hand, the rings would be wider than your dinner table, but thinner than a strand of spider silk. There's no need to picture the math precisely. Just let the thinness of it settle in your mind. A thing so wide it could swallow worlds. A thing so thin it could pass through a hand. And so, somewhere out there, a single piece of ice is catching the light of a distant sun, no different from the light that fell on a windowsill tonight. The same patient star is touching both the ring and the room you are in. It's the kind of thought you can let dissolve, slowly, without holding on to it. The rings are not solid. They never were. For a long time, people imagined them as a kind of disc, smooth and continuous, like a record on a turntable. But the truth is gentler than that. In the year 1857, a Scottish physicist named James Clerk Maxwell sat down with the mathematics of the matter and found something quietly beautiful. A solid ring around a planet, he showed, could not survive. It would break apart, slowly but certainly, under the pull of the planet's own gravity. The only way the rings could be there at all, the math told him, was if they were made of many smaller things, countless small things, each one circling Saturn on its own. That is what we now know to be true. The rings of Saturn are made of billions, perhaps trillions, of separate pieces. Most of them are ice. Some are smaller than a grain of sand. Some are about the size of a snowball. A few are as large as a house, and a small handful are the size of small mountains. Each one is its own quiet object, drifting around Saturn on its own slow path, taking somewhere between 7 and 14 hours to complete a single loop, depending on how far out it sits. None of them touches the others most of the time. They simply drift in the same direction, in the same plane, like a slow snowfall that has forgotten to fall. Let's drift a little further. The rings are not one ring. They are 7, named simply with letters, in the order they were discovered. From the innermost outward, they are D, then C, then B, then A, then F, then G, and finally E. There's no need to remember them in order. It's enough to know that each one has a slightly different character. The B ring is the brightest and densest. The A ring is the second brightest, easily seen through a telescope from a backyard on Earth. The C ring is fainter, more translucent, the way a pane of frosted glass might let some of the light through. The D ring is closest to Saturn, and very faint indeed. The F ring is narrow and strange. The G and E rings drift far beyond the others, so wide and so thin that they seem to be made more of memory than of matter. Between the brightest 2 rings, A and B, there is a quiet gap. It is called the Cassini division, named after the Italian-French astronomer Giovanni Cassini, who first noticed it in the year 1675. He had a better telescope than Galileo, and patience, and a willingness to look for the same thing many nights in a row. From a distance, the gap appears empty. Up close, it is not. There are particles in the Cassini division, just fewer of them, and they orbit in a slightly different rhythm. The gap is held open, gently, by the pull of one of Saturn's small moons, the one called Mimas. Each particle that drifts into the gap is nudged out of it again, in a pattern that has been repeating quietly for as long as the rings have existed. Here's another quiet thought. The rings, altogether, are almost entirely water ice. Somewhere between 93 and 95% of what you would find, if you reached out and caught a handful, is the same frozen water that falls from a winter sky on Earth. The rest is mostly tiny grains of darker material, small bits of dust and ancient soot, the soft remnants of meteoroids that have wandered through the system over a long time. The mixture gives the rings their faint, creamy color when you see them in close detail. From farther away, they look almost pure white. From farther still, they look like a single soft brush of light painted across the dark. You can imagine them, if you like, as something familiar, a wide pond of frozen water, broken into uncountable small pieces, all turning around the same gentle center, or a slow snowstorm suspended in space that never lands, or a great frozen river flowing around the planet in a perfect, patient circle. Any of these images is close enough. None of them is exactly right. The rings are simply themselves, and they have been themselves for a very long time, without needing to resemble anything else. And if we drift in close enough, closer than any telescope has ever let us see directly, we would find that each ring is made of countless small worlds, each piece of ice doing its own slow work in the same hush. So let's drift in closer now. Closer than any spacecraft has flown. Closer than any human eye has seen. Closer than the rings have ever been described in a book. Imagine drifting until the great wide disk of the rings is no longer a disk at all, but a slow rain of separate pieces scattered around you on every side. Some are passing nearby, most are far. The ones close enough to see are turning, slowly, in the dim light of a sun that is very far away. This is what the rings actually are, when you stop looking at them from a distance. A loose, drifting cloud of small ice particles, each one a kind of small world, doing nothing in particular. Some are smaller than a grain of sand. Many are about the size of a snowball. A few are the size of a stone, or a chair, or a small car, and a rare few are as large as a hill, or even a small mountain. The very largest are far apart, and you would only meet one once in a long while. The smaller ones are everywhere, drifting past, almost like a soft fog. Slowly now, let's hold one in mind. A single piece of ring ice, about the size of a snowball, you could cup in 2 hands. It is not a special piece. It is one of trillions. It is made almost entirely of water, frozen into a soft, slightly grainy shape, with a few specks of darker dust caught inside. It has been turning on its own slow path around Saturn for as long as the rings have existed. It has never been alone. It has never been touched. It has simply drifted in the soft company of others like it, around and around, since long before anyone on Earth knew the rings were there. If you could stand on it, gently, the world around you would be strange and quiet. Saturn would be enormous in one direction, soft and banded, a great pale presence filling much of your sky. The other ring particles, the nearby ones, would drift past at the same speed you were moving, so they would seem almost still, like leaves on a slow river that you are also a leaf on. Farther out, they would seem to move a little faster because they are. Farther in, a little slower because they are. Above you, the sun would be a small, bright point, no larger than it appears from Earth, and the rest of the sky would be soft black, sprinkled with quiet stars. Once in a while, gently, your particle would meet another, not collide, in the way one car meets another. The contact would be soft, slow, almost tender. 2 pieces of ice, drifting at nearly the same speed, would touch and slip apart again, leaving each other only slightly changed. This happens all across the rings, all the time. Each piece of ice has been kissed by countless others in soft, drifting passes over a very long time. None of these contacts is sudden. None of them is loud. They are simply what happens when many small things share the same patient orbit. By the time you finish this sentence, that piece of ice has drifted another 1.5 miles along its quiet path, still without anyone watching. And by the time you read the next paragraph, it will have moved farther still and farther still after that. And it will keep moving gently for as long as the rings remain. There is something restful about that. The orbit does not require attention. It does not need to be cheered on. It simply continues. In the very brightest of the main rings, the B ring, the particles are so close to each other that the ring is almost crowded. Even there, though, the crowding is gentle. The particles are packed loosely, like a slow snowfall caught in the air, and they touch and drift, in a rhythm that has been going on for a very long time. The B ring is the brightest because of this packing. More ice, catching more light, sending more of it gently back towards space, onward, gently. There is something else worth letting settle about the rings, which is that they are not entirely alone. They share their space with small moons, not the famous large moons of Saturn, like Titan or Enceladus, but a quieter family, tiny moons. Some of them only 10 or 20 miles across. Some of them so small they were not discovered until the Cassini spacecraft passed close by. In the early years of this century, these small moons live among the rings, and they have a soft job to do. Inside the A ring, there is a small gap, only about 300 kilometers wide, called the Encke Gap. Sitting in the middle of this gap is a tiny moon named Pan. Pan is only about 28 kilometers across, smaller than many cities. As Pan moves along its orbit, its small gravity gently sweeps the ring particles to either side, keeping the gap open, the way a hand might smooth a sheet on a bed. The gap is not really empty. There are still a few particles inside it, but most of the ice has been quietly nudged out by the patient work of one small moon, doing the same gentle thing over and over for as long as the rings have been there. Farther out, there is a thin, narrow ring called the F ring. It is one of the strangest of the rings because it is so narrow. Most of the rings spread out, soft and wide. The F ring is held tight, almost like a length of ribbon. The reason for this is two more small moons, named Prometheus and Pandora. They orbit on either side of the F ring, and their small gravities keep the ring particles from drifting too far in either direction. Astronomers call these kinds of moons shepherd moons because they shepherd the ring, like a quiet hand on the edge of a tablecloth, keeping it from sliding off. And in the same hush, the rings sometimes show stranger features, ones that do not last very long. In the brightest part of the B ring, dark patterns sometimes appear, stretching across the ring like soft shadows. They are called spokes. Each one is made of tiny dust particles, lifted just above the ring by a quiet electric charge. The spokes appear slowly, and they last for only a few hours, and then they fade. Astronomers have watched them come and go for decades. They are still not entirely sure why the spokes form when they do. The rings, even after all the watching, still have small surprises in them, soft ones, the kind you can let drift past without needing to understand. Here's another small wonder. The outermost of the main rings, the E ring, is being fed, even now, by a small moon, far out from Saturn. The moon Enceladus is mostly a ball of ice, with a slow, hidden ocean underneath. From the south pole of Enceladus, gentle plumes of water vapor and ice are rising, slowly, into space, not in great fountains, but in soft, drifting curtains. Each plume sends fresh ice particles drifting outward and a portion of that ice settles gently into the E-ring. The ring is being replenished, one small grain at a time, by a moon that does not know it is doing this. The water that joins the ring tonight will join the slow procession that has been turning around Saturn for longer than any record we keep. You can hold that thought for a moment, if you like. A small moon, far away, soft plumes rising from its quiet south, a faint ring drifting outward, made of the water that the moon has gently let go. None of it is sudden, none of it is loud. It has simply been happening for as long as the system has existed, and it will keep happening after this. The rings are full of these soft arrangements, small moons keeping things tidy, tiny moonlets carving out gaps, spokes appearing and fading like breath on glass, water from one moon settling into a ring made of older water still, everything in slow conversation, everything gentle, nothing in a hurry. And yet, gentle as the present is, the rings have a longer story still, one that stretches both backward and forward in time, a story you don't need to follow closely, but might find restful if you let it drift past, slowly, now. There is a question about the rings that astronomers are still gently asking and have not yet fully answered. The question is simple enough. How old are they? For a long time, most people who studied the rings assumed they were as old as Saturn itself. Saturn formed, like the rest of the planets in our solar system, about 4.5 billion years ago, in the slow settling of dust and gas around the young sun. It seemed natural to imagine that the rings had been there all along, that they were a leftover, a piece of the original material that never quite came together into a moon. That assumption held for many decades. It was a tidy explanation and a comfortable one. But over the past few decades, slowly, the picture has shifted. When the Cassini spacecraft arrived at Saturn in the year 2004, it spent 13 years drifting close to the rings. It looked at them from many angles. It measured their mass. It studied the way they reflected light. And what it found, in the end, was something quietly surprising. The rings, by every measurement, looked young. The ice in the rings is too clean. That is the simplest way to put it. Out in space, even in the quietest places, there is a slow drift of tiny meteoroids, soft as dust, moving in all directions. Over a long time, these tiny grains rain down on anything they pass, darkening it, slowly. Old ice, exposed to space for billions of years, becomes dim and grey. But the ice in Saturn's rings is bright, almost pristine. The kind of brightness that, by current understanding, can only belong to something that has not been there for very long. If you're still with me, here is the thought. The rings of Saturn may not be ancient at all. They may have formed somewhere between 100 million and 400 million years ago, which, on a cosmic clock, is recent. So recent that they may have appeared while the first dinosaurs were walking on Earth, or somewhat after them, or somewhat before. The exact timing is still gentle, still soft at the edges. And if the rings are young, then they must have come from somewhere. Something must have given itself, somewhere along the way, to make them. There is a theory proposed by a group of astronomers at MIT a few years ago that gives this missing something a name. They call it chrysalis. In their picture, chrysalis was once a moon of Saturn, about the size of one of the larger moons we still see today. For a long time, it orbited quietly, and then, slowly, over a few 100 million years, the gravity of the moon Titan began to nudge Chrysalis into a less stable path. The orbits drifted, the pull grew uneven, and eventually, perhaps 100 to 200 million years ago, Chrysalis came too close to Saturn. The planet's gravity, gentle but firm, pulled the moon apart. Most of what had been Chrysalis fell into Saturn, slowly, but the outer layers, the icy parts, drifted into orbit, and over time, they settled into the wide, thin disk we see tonight. It is only a theory. Other astronomers have proposed slightly different stories. Some think two small icy moons may have collided long ago, and the rings are the soft remains. Some still wonder whether the rings might be older than they look. The full answer is not yet known. The scientists who study this are patient. They take their time. But the picture that is becoming most likely, the picture that fits the cleanest with what Cassini saw, is the one with Chrysalis in it. A moon that was once whole and is now drifting around Saturn in countless small pieces. The name itself feels right somehow. Chrysalis, a word for something that was once one shape and has become another. Not lost, exactly, just slowly, quietly, transformed. You and the rings, in the end, are made of the same patient water, the same hydrogen, the same oxygen, the same long history of being held together by gentle laws. The water in the rings tonight may have once been part of a moon. The water in your body has, in its own way, been part of many things. Rivers, oceans, clouds, rain. It is older than the cup it now sits in. It is older than the body it now passes through. It has been somewhere else before, and it will be somewhere else again. There's something else worth letting settle. The rings, even now, are very slowly disappearing. It is one of the quietest discoveries of the Cassini mission, made during its final years, when the spacecraft was drifting between Saturn and the inner edge of the rings. The instruments noticed something gentle, a soft, steady rain of water falling from the rings into Saturn's upper atmosphere. Not much, by Earth standards, about the volume of an Olympic swimming pool every half hour or so. But over millions of years, that slow rain adds up. Astronomers have a soft phrase for this. They call it ring rain. The picture is exactly what it sounds like. Tiny particles of ice drifting from the inner edge of the rings, slowly losing their orbit, slowly falling toward the planet below. Each particle on its own is too small to notice. The rain is so light it would not wet a hand. But it has been falling for a long while, and it is still falling tonight as we drift here, and it will keep falling for a long while after. Given the rate of this rain and the mass of the rings that remain, astronomers can do a soft kind of arithmetic. The numbers say that the rings, in their current form, may not last forever. They may fade, slowly, over the next 100 to 300 million years, which sounds long, and in human terms, it is. But in the life of a planet, it is brief. The rings of Saturn on the cosmic clock are something like a passing weather. They were not there for most of Saturn's history, and they will not be there for most of what comes next. Quietly, that means something. Whatever first puzzled Galileo when he turned his telescope towards Saturn in 1610 was a window, not a permanent feature of the sky, a view briefly open. The rings happen to be at their fullest, brightest, most visible right now. 400 years ago, The people on Earth who first saw them were inside that window. 400 million years from now, whoever might be looking at Saturn will likely see only a faint trace or nothing at all. We are inside the window too. The rings, as we know them, belong to our small slice of time. Another small wonder, the same water that is falling gently from the rings into Saturn tonight has been doing what water does all across the universe for a very long time, drifting, settling, letting go, becoming something else. The rings are not separate from the rest of the cosmic story. They are one of its slower chapters, water held in place for a while by gentle gravity before it moves on. If you're still with me, here is one last thought before the rings begin to fade from view. The thinness of them, the patience of them, the slow turning, the soft rain. None of it asks anything of you. The rings do not need to be noticed to keep doing what they do. The ice particles do not need to be counted. The shepherd moons do not need to be thanked for their quiet work. Pan keeps sweeping the Enki gap, whether or not anyone is watching. Prometheus and Pandora keep tending the F-ring, whether or not anyone has named them. Enceladus keeps releasing its soft plumes, whether or not the E-ring is full or thin. Chrysalis, if it ever existed, has already become what it became, and is now drifting in countless small pieces, doing the patient work of being a ring. There is something restful about all of it, the way the universe seems content to keep going, gently, in the dark, with no audience, no reward, no destination. The rings are just one example, a particularly beautiful one, but the same patience is everywhere, in every quiet corner of the cosmos, if you let yourself see it. And so, slowly, we drift back, out from between the particles, back through the wide, thin disk, away from the small shepherd moons, away from Saturn itself, until the planet is once again a small, soft shape against the dark, with its rings drawn around it like a quiet thought. The rings keep turning. Tonight, tomorrow, for a long while yet. There's nothing more to remember, nothing more to picture. You can let it all soften now into the dim of the room you're in. The rings are still there, still turning, still slowly raining down their patient water. Pan is still sweeping, Enceladus is still gifting. The light of a far sun is still catching, gently, on countless small pieces of ice. It is happening, even as you breathe. And somewhere in the same universe, your breathing has already begun to slow. Your shoulders have softened. The day is letting go of you. The rings will keep their slow promise, whether you are listening or not. You don't have to come back. You don't have to remember any of this. The patient water has been patient for a long time. It can be patient a little longer while you rest. Sleep well.